Today we're going to be learning the power rule, and that's one of the easiest things we could learn in derivatives. So what the power rule states is that the derivative with respect to x of x to the n power is going to equal n times x to the n minus 1. It will make more sense when we see this rule in action, so let's try x squared. First, we're going to pull the exponent to the front, as they do in the original equation, and then we will drop the exponent by 1, giving us 2x to the power of 1, which is just 2x, and that is going to be our final answer. So let's try another problem. Having a 6 in front doesn't change anything. We're still going to move the exponent to the front, and then we're just going to multiply that with the 6, and then we're going to drop that exponent by 1, which will leave us with 24x to the third power. The negatives also don't change anything. We're still going to multiply the coefficient and the exponent together, and then drop the exponent by 1, which will give us 50x to the negative 11th power. Make sure that you're subtracting 1 from the exponent, even if it's negative, rather than adding it. That's a common mistake. Taking the derivative of 4 or other constants and numbers that have no variables attached is the same as taking the derivative of 4x to the 0 power, since anything to the 0 power is just 1. When you move that exponent of 0 to the front and multiply it with the 4, you get an answer of just 0. So numbers like 4 and 5 and others will all have a derivative of 0. When taking the derivative of a number like this, I would split up the numbers individually so you don't have to go through the quotient rule. And in doing so, you can cancel out the x's in the numerator and the denominator, which will leave you with just 4x to the third minus 7x squared plus 3x to the negative 2. Alright, so why don't you try taking the derivative of this first number? 12x squared, yes. And then the next number is going to be negative 14x. And the third number is going to be negative 6x to the negative third. Now, since it is a negative exponent, you're going to want to make that into a fraction just so you don't have a negative exponent. Moving on, we're given that the function f of x equals 3x to the third minus 8x squared minus 2x, and we're asked to find the equation of the tangent line at x equals 3. We're already given the x value, so we can plug that right into the equation. All we have to do is find the y1 value and the slope. In order to find the y1 value, you have to plug in the x value that you're given into the original function. That will give us 3 times 3 to the third minus 8 times 3 squared minus 2 times 3. And that's going to give us 81 minus 72 minus 6. And that's the answer for that is just going to be 3. In order to find the slope, however, we'll have to first find the derivative of that function and then plug in the given x value. So now we're going to say that f prime of x equals 9x squared because we're moving that exponent to the front and multiplying with 3. And then we're going to say minus 16x and then minus 2. Are there any questions about that? Alright, awesome. And then from there we're going to plug in that 3 for the x, and it's going to get f prime of 3 equals 9 times 3 squared minus 16 times 3 minus 2, which is just going to equal 81 minus 48 minus 2, which equals 31. So that's going to be our final slope. So now let's try a real-world problem. The position of a car is given by s of t equals t to the third plus 2t squared minus t. Find the velocity after 3 seconds. So the velocity is just the derivative of the position equation. So v of t is just going to equal, well, what's the derivative of this? That's going to be 3t squared plus derivative of this, that's just going to be 4t minus 1. And since we're given a time, we're just going to plug that in. So v of 3 is going to equal 3 times 3 squared plus 4 times 3 minus 1. And that's going to equal 27 plus 12 minus 1, which is going to equal 38. And that is our final velocity. Thank you for watching.